Hello everyone. Welcome to the event. This is Sayankit, the lead of GDSC Bits Hyderabad. And today the session is about introduction to open source, Git and GitHub, and also some small insights about Hacktober Fest and how to submit good quality PRs and not randomly spam the repositories. The speaker for today is Tanya Prasad, who's a 18 batch DLite. She's a Red Hat intern. She finished a GSOC from Aussie, and she's an incoming Microsoft software engineering intern. Now, I'll give the stream to her. I'll let her handle it, and I hope you enjoy the stream.
Hello, everyone. I am Tanya, as he said, and I'm here to talk about open source Git and like getting into the programming world in general and how to do it right, rather. So, can I share my screen? I do have a presentation to like guide us through this uh, session. So, let me start with like what is open source and like instead of starting from this, let's start from how there are like two kinds of softwares in the entire world. One's proprietary softwares, and then you have open source softwares. So proprietary softwares are like owned by organizations, people, and are in general and are necessarily private. Like us or you cannot just in general see them or like contribute to them, the code or the project. And in fact, there's so like most of the tech companies follow this. All of their code and repositories are secret. Like only the employees can see it and they contribute to it. And you're even made to sign non-disclosure agreements that you cannot talk about them outside of work. So this is a very private sector, private field, private code, you could say. Yeah, and you open source is the opposite of that, like literally polar opposite. So you have repositories, anybody can see them. Repositories are essentially like code folders with have code in them, and like anybody can see it. You do not have to be a part of an organization. You do not have to be employed by somebody. You do not have to be added to that repository to see them. Essentially, you do not need any permission to see the code. And what is more, uh, one step further is that you can even contribute to them as anybody. Like you can be a student, high schooler, retiree, um, middle age. It doesn't really matter as long as you have the skills and the contribution you're making is valuable to the person or the organization maintaining that code base, they will accept it. And so this became a really up and coming phenomena today. Uh, so what is open source formally? Like it's just a term that is used for open source software, like I just told you. Uh, and it's like it promotes transparency, you could say, but like moreover, nowadays what's happening is like even big tech firms like take Google, take Microsoft, they're all investing in open source. Like they're making some of their projects open source. So why are they doing this? Is like for multiple reasons. A, it promotes transparency. You get to see everything that they're doing, and B, like they want people that are not working for them, and in fact some of them that are even working for competitive companies, like they they compete in terms of products to still contribute to a common uh, product that would help both of them. And in this way they promote, they they first of all, they do not have to put all the resources, like a single firm does not have to put all the resources in developing it. And at the same time, other firms can also, like when many people contribute to it, you are open to new ideas because you're geographically different, you're taught by different people, you learn from different societies. So they just makes to it just helps to get very creative solutions. So that was why it came around very famous, came around to be very famous today. So for example, you have some softwares like Linux is fully open source, and then you have TensorFlow, the machine learning library, fully open source. You have Python, the language, open source. You have Blender, the rendering software. I don't know, that's also open source. So these are famous. I mean, Firefox is open source. Like, I mean, you name it, you almost use it every single day. So this is a way, like, and it so happens that sometimes organizations, they take these open source solutions and then they make enterprise versions of it, which guarantee more security, reliability, maintenance, etc. So, like, it's a very nice way to get introduced to it at this point, because it's a forever growing community, and it's just teaches you so much of good practices that I would extremely recommend being part of something in the open source world. And the good part is that it has something for every skill level. Like, you do not have to be a really experienced programmer. I mean, you can just be out of high school, or like first or second year of college, and you can still contribute to production level code. So that was a little introduction in open source. And now we come to Git and GitHub. So are they the same thing as this GIF is showing us? Well, no. Most people attribute these two to the same entity, but in fact, they are two separate services. So Git is a version control system in itself. Like, it does not have to be associated with GitHub or any other such alternative. Git is like, you have, it's used to, so basically, imagine, like, we all did this in grade school. Like, we were making presentations for school, or we were making something for school, and then you would make version 1 of it, and then you would make some changes, and then say the same file as version 2, and then at the end your entire folder is just full of version 1, 2, 3, final, big mess. But what happens now is, like, the guy who created Linux, he realized this, like, tracking code changes was even more harder because you have multiple people working on it, like, and they're all working on different things, and how do you bring them all together without much of a mess? Well, so Linus Torvalds created Git. So this was used to track code changes, as in every time you make a code change and you want to keep it permanently, you mark it or tag it, and then it goes into its configuration file, and from there it keeps getting stacked as you make a change after change. And at any point you can, like, move between changes, change versions, keep work, or I mean, that's kind of what it is. Is Git the only thing that can do this? No. So Git has an alternative. There's Apache Subversion. It goes by SVN, but it's not that widely used because Git is more user friendly. It's easier for, like, new people to learn. So and its commands are a little more easier, you could say. And GitHub is a cloud service. Essentially, it's like a backup system, or like a deployment system for your code. So if you make an application in your local machine, and then you want to, like, get other people to contribute to it. I mean, so you share it in a common space like GitHub, and then you can add other people to work on it, or like you can showcase your code, or like now you can even deploy your code. In fact, you can also run like CI/CD pipelines and all of that. And is GitHub the only thing that can do this? Nope. So there are other services. So you have GitLab, which also supports Git, and like it has more or less the same features. It's more of a preference thing, who prefers what. So that's a little bit about GitHub. And Git and GitHub have certain terms and like that you need to know, because it's a skill that is learned, like it's a software. So most of the key words that we use in the Git and GitHub world are like repository. So a repository is it derives from its English meaning only. It's like a collection of something. And in the context of code, it's a collection of code. And mostly it's a folder. It's a folder of all your files. And that is called a repository. So every repository comes with its own permissions, uh, like access control, and like uh, its own uh, capsule of things. And you can clone a repository. So clone is one of the Git commands. So now a repository, if your repository is on GitHub or GitLab, and like you need to bring it to your system or like any system in general, so you would go to the command line and go git clone. So the entire repository gets copied to your system, and then you can work on it. So that brings to the next part. So when you're editing stuff and changing stuff and like make adding new features, what happens? And you need to like, and you're like, yeah, this feature is done. Let's like commit it. Like we're not going to change anything for now here. Let's just commit it. It's a checkpoint kind of thing. So you commit that status of files as a commit message or like a commit command. So that goes like git commit, and then okay. So I should tell you like, so the Git software is a command line software. So you have typical Git commands. So all of these clones, clone, commit, push, pull, all of these are the commands. So every time you want to do one of these, you hit the Git command. There are a lot of commands. These are just like into stuff. So yeah, coming back to it. So now that you've committed a certain feature, and all of these configurations are saved in your .git file in your folder. So this is a hidden file. Like usually when you do ls or anything, you probably won't see it. But if you enable hidden file option, then you can see .git, and all of your configurations are stored in this. Yeah. So now that you have finished your commit, you committed git commit, and then every commit is accompanied by a commit message. So uh, uh, whatever feature you build, suppose I say I just build a login screen, so I'm going to say, yeah, the login screen is done, like committing it or something like that. And now that state of file is saved. And each commit has a commit hash associated with it. So uh, this is unique. It's a unique string that every commit has, and you get this helps you identify each change that you've made, and then like go back and forth between it. Like you can switch around with it. And so now that your feature is done, and you're like, yeah, I should back it up in GitHub or like push it to GitHub so somebody else can access it and build up on it, etc. So then you push it to GitHub. So this is called a push. So when you push something from your local system to a cloud service, then you push it, and it's followed by the git command push. And this would require you to have access to the repository. So if you own it or like if you're added as a contributor to it, you can push directly to the repository. Uh, Otherwise, you really can't. Like you just don't have access to change that file. And what's git pull? So now that you have pushed your changes to the cloud, to one of these cloud services, GitHub, uh, and your friend has done his part. He has made his changes and put them there on the. Now you want to like see what are the changes that he has or she has done. So now you have to bring back the current state of the GitHub repository to your local machine, and that at that point we do a git pull command. So this updates your local repository with all the latest changes, and it brings your uh, code base to as current as it can get, so that you can test it out and like see add new features, etc. Now coming to the next thing, what are branches? So branches, yeah. So branches in general are like, so you have a current state of your repository, and you don't want to disturb this right now. Like, this is your main code, and anything you do to it might break it. So like, and like, is it really wise to mess with it at this point? So the Git has a feature where you can make branches. So branches are like your, it's literally like it makes a copy, which has its own history, and like you can keep working on it, and there would be no change to the original line of code. Like, this would just be an alternative copy that exists, and you can just keep working on it, and when you know that the new feature or the bug is fixed, then you can merge it with the old sequence of code. Like, so I'm not sure if that was clear. I think I'll make it more clear on the next slide. And what's a pull request? So a pull request is something like, um, so now you have made you were originally working on so basically there is a project that exists, but you don't. Okay, let me say it as an analogy like this. So there's a project that exists, but like you're not allowed to directly commit to it because you don't own it. So like, how do you like send your code to it? Like, how do you say, hey, I'm going to commit to it? Like, I want to push my contribution to this, but like you're not letting me do it by a push or a commit. So like, how do I do it? And then so there'd be like, hey, submit a pull request. So a pull request is rather a misnomer. It's uh, it's more like a merge request. So you made all your contribution to your copy of the original repository, and then you just say, hey, it's ready. It's ready to be incorporated with your product. Here's my merge request. Essentially, now you can merge your contribution with the original product, and it would be good to go. So you submit this kind of a request in something that's called a pull request, and mostly this is how features are added because it's good practice. Because pull requests are like really exhaustive. Like, you have a huge description to write. You have like sometimes CI/CD pipelines integrated to it. Like, there's a whole thing on it. So now you have submitted your pull request saying, "Hey, my contribution is done. Here's my code. I'm going to merge it with your code," and the, you submit the request, and then you all, and then after that you just happen to get hi. So the question. No. So a pull request is not a branch. Okay. So you have, wait, let me just show you. Is that okay? Yeah. So this is the repository. This is my original code. There are three branches to it. And there is a pull request open here. So look, this is what a pull request looks like. So my friend Jonathan, he added a new feature to the repository. In fact, this was a bug fix. So what he did was he had a copy of the same repository, and he's just saying, from this copy, merge that copy into my copy. So it's something like that. It's not a branch. It does not create a branch. What you can do is, if you own the repository, then you can create another branch and then merge it with another branch. Like, I can merge. So if I do a pull request, if I do new pull request, then it tells me which branch do I merge with which branch. Like, I can merge this one to this and open a pull request. So it's with one copy of code to another copy of code, and how do you want to like merge it? That's how pull request works. Pull request does not make any change to the either of the repositories, like your copy or the original repository. It's just a request to say, hey, these are the changes, you might want to pull it. So it's something like that. Was that okay? Yeah. Okay. So another two important things to know is upstream and downstream. I will come to this in a minute, in just a minute, like in the next slide or something. And the last thing we need to know are licenses. So I just said that, yeah, so you can do anything with the open source code. Like you can borrow, you can like refer to it, you can read it, you can do anything. Does that actually mean you can do everything? Like you can rip someone else's code off or like sell it for a certain amount of money? So yeah, so we have protections against such things. They call licenses. Okay. So along with your code, you can also send a license. You can also attach a license file, and that says to anybody who uses that piece of code what they can do with it. So it's free to use these. I mean, it's just like a honor thing, like you honor it. Uh, yeah. So there are many types of licenses. So there are uh, like you have the MIT license, which lets the borrower of the code do anything they want with it. I mean, there are like literally no bounds to it. It's the most lenient license you can get. And no, I'll come to you in like 10 minutes when I'm at the pull request slide. So just wait for a minute. Techie Junior, yeah. Yeah, so that licenses are like, so you have the MIT license that can allow you to do anything with the code. And then you have the GNU GPL v3 license. Sorry, I'm not sure I said that right, but yeah. So this is a kind of license that forces anybody who uh, uses that code to also make their code open source. So it's something like that. So you have many licenses that you can use, and it's very important to honor these licenses when you are using somebody else's code, because like it's not really ethical to not use them. So I thought it was a like make sure you read the licenses before you do anything with anybody's code. So yeah, branches, revisiting branches. So imagine this was so all of these. So this is your original sequence of uh, code. So here's what you started with. This is the master. So essentially, all of these are commits. Okay, all of these circles are commits, checkpoints. You could say like you can travel between these commits, and now you can make a branch. As in, you do not want to disturb this line of work. So because this might be in production, like this entire thing might be deployed and people may be using it, so you can't risk directly just pushing code to it and like it breaking and without testing, etc. So now you create a branch, so you just separate your work from the main version, and then you do your work, and now we submit a merge request here and it merges to the original code. And similarly, like there are multiple people working on it, they can uh, create multiple branches and then merge all of it to the master. So the main branch that is followed, like the one that has the optimum final code, is was called the master like until very recently, and now it's defaultly named as main. So that's what a branch is like. It's just a copy made at this point in time that you can make changes to and then remerge it to the master. uh yeah, so you can. Okay, what are forks? Very important. So like I said, you can't directly contribute to somebody else's repository. You need to send a pull request. So like, how do you do this? You need their copy of code, right? To like first work on and then put features and then send a pull request. So there's something called a forks. So you can fork a repository so that the entire repository that belonged to somebody else is copied into your account, and essentially you just get a copy of that repository to do anything you want with. It's your own copy. It's just exactly the same, and you have all permissions to commit, read, like push to it, add other people to work on it. It doesn't matter. Like it's as if it was your own repository. And from here is when you either like make changes for yourself and make it to a totally different product as it was, or you contribute to the original repository. So once you're done with the changes that you make here in this repository, you can submit a pull request from one of the branches in your forked repository to one of the branches in the main repository. So that's how pull requests work. Like, so yeah, the revisiting pull request, it's an event where a contributor asks a maintainer to review the code they want to merge into a project. So that is the official words in which it's said. Hopefully, it'll become a little more clear now. But if it doesn't, feel free to leave comments or like ask questions. That brings us to some other topic. Another topic, we are celebrating Hacktober Fest. It's October, so it's a month-long celebration of open source. Here are some facts about it, but like mostly it's just like it's an entry point into the open source world. So if you know some skill, I mean, you don't have to be very skilled. If you know just basic HTML, CSS, or even just C programming, it's just a way to contribute into something, an open project that would make significant impact. Uh, so um, and it's placed very strategically in October, I would say, because if you join the community now, like then you get a whole get some experience in 3 4 months, and then you can apply for other open source competitions like or programs like Outreach, GSOC, uh, Girl Script, Summer, Bitcoin, and all of it's just a whole horde of events. So, how do you participate in this? So, uh, GitHub, it's hosted on GitHub, and uh, uh, a lot of repositories on GitHub have the Hacktober Fest tag associated with it. So like anybody can make their repository a Hacktober Fest repository. Like um, so all you have to do is fork that repository, make your changes, and send a pull request. Oh, I know that voice. Okay, good. Uh, Hi there. Uh, uh, okay. So essentially, just try to get your first 4 PRs in, because getting your PRs accepted is also an art. Like it takes people a long time to make quality PRs, like our viewer said. But yeah, so practicing early how to make proper pull requests, because your code has to be readable, it has to be understood by people who contribute to it after you, and then your description has to be good because the maintainer has to see what are the new features that you have added and etc. So learning to make good pull requests in Hacktoberfest is like life changing skills, and it's easier to like learn it now rather than when you're doing your internship or like working, because then the uh, learning curve will be very very steep. So these are reasons why you should contribute to Hacktoberfest. And yeah, as an addition, you get to earn a t-shirt or plant a tree. I mean, save the planet. You have enough t-shirts, plant a tree. So, so this is what Hacktoberfest is. It doesn't take any money to participate. We'll see how you can participate. So, you participate in like any repository that's in GitHub? No, that's not how it works. Like the owner of of all repositories on GitHub have the right to make their repository, a Hacktober Fest repository, and it's just up to them. Do they want to like allow people to contribute as a part of Hacktober Fest? So a lot of repositories have their uh, repository associated with the Hacktober Fest tag or label. And if you want to find the entire list, go to this URL. It's in the description, and find a project you like. If it seems like you can contribute to it at any skill level, go for it. And in fact, if you want to participate in this, and one of your friends and you're familiar with some of your friends' projects, and you can convince them to make it a Hacktoberfest repository and like send pull requests to them, that would also work. So it's a good way to contribute with other people, and it's a good experience to see how it is contributing to a project that has multiple people working on it, uh, because that is also a skill. Like, how do you work in total synchrony with somebody else? And now, how do you get started? I hope it was clear. I mean, you can pause for questions. Yeah, okay. So, if you're clear on what a repository is, find a repository. Every repository has a fork option. So, fork it, get a copy of your own. And here's where we come back to the terms upstream and downstream. So, your original repository is an upstream of your fork repository, and your fork repository is an downstream of your original repository. And this goes for any repository. Like, your fork can have another fork, like somebody else can fork it, and that would become a downstream of your fork repository, etc. It's just a cascading thing. So that's what upstream and downstream was. So now that you have your own copy of the code, you can work on it, like code it, like add features, fix bugs, do whatever you want, like in your local system, and then you push the changes to back to your forked repository on GitHub, and then you submit a pull request from your forked repository branch to the original branch in the main repository. So is that okay? I mean, a pull request is a merge request, as in it merges your code, repeating. Yep. So yeah, now you have chosen to make multiple contributions to the same repository. So essentially, it's like, okay, this is a website, and your first pull request was a login page of the website, and now the maintainer of that repository says, okay, great, this works for me. This is a very good PR. I'm going to accept it. Now PR is accepted. Now you're like, okay, I'm going to make the sign up page for this particular web application too, and then send another PR. So the point is that at this point, sorry, bad choice of words. Yeah. So the point is that now the act of the maintainer of that repository accepting your PR is also a commit. So you, while you're making changes and sending new features through your forked repository, you also have to make sure that it's at the most recent uh, version of the main repository. Like, the commit should be pulled from the main repository to your repository. Essentially, always make sure that you are in line with the upstream, and otherwise pull changes, because it becomes a really big pain when you have missing commits. Like, suppose your main repository, somebody else made two more commits to it, and now your current fork repository is not up to date. So you have to fetch upstream, or like fetch fetch changes from the old repository. And this happens every time somebody makes a commit to the original repository. So now it's also important to remember that when your PR got accepted, that is also a commit on the main repository. So even if it's just you committing to that repository, make sure that you pull the changes and then send in a new PR. So it's a problem. I stress on this because uh, I stress on this because if you have missing commits, then you'll have to rebase. So rebase is another Git operation where you have to essentially go back in time and reorder commits to be applied on one after each other in the right order. And that leads to a lot of merge conflicts a lot of times, and which is in simple words a big pain. Rebases should be avoided as much as you can, but they cannot. And many, if like people are contributing to the same project, you cannot avoid a rebase, but like make sure that there's no rebase because of you, because that would just be unnecessary big pain. So make sure you fetch your commits from upstream as regularly as possible, including your own PRs. Now, going to resources. So, as you have seen, I didn't particularly teach GitHub, and that was for a reason that I just wanted everybody to know. And the purpose of this was to just give an overview, because I am not the best person to teach Git. Like, there are people with millions of views and like industry level projects that have better tutorials than me. I could just give you an overview of why we need this. So here are resources to learn it. Trusted ones, these are really good. So all of the links are in the description. Uh, so this one is a Git tutorial. It's like more of a documentation sort of thing. It's really good. Like if you want to start out, and if you're like more of a reading person, then go with this. Otherwise, this is an intermediate. Sorry, this is a beginner level YouTube video, and this is an intermediate YouTube level video. This has a lot about how to make good PRs and how to like make sure that your PRs get accepted. And this is a link for open source programs that you can apply to throughout the year. I mean, some of them are paid, some of them are unpaid, but like they do give you insight into like uh, just how open source works. So if you're interested, links are in the description. And my presentation ends here, but since this was more of me just talking and throwing terms, uh, the I was also told to try to give a demo, so how things would look like in actual GitHub and like how to do certain things. So if you're interested, I'll start that now. Uh, my screen again. Yeah, thanks. So yeah, as I was saying, sorry, let's go back here. Yeah, this is what a repository looks like. So you have its description, you have all of the files here, and you have the README. So README is very good, very important. So if you ever make a repository, make sure that it has a very informative README, because it's like if somebody else reads, if comes across a repository, they might not be able to make sense of the code because it's probably not their skill set, or like the code might not be commented. Basically, you don't really have time to read the code. So this README provides you like a space to showcase what the code actually does. So like write about write about like what the product is, how to use it, features, pictures, like how to contribute to it, like etc. So like I was saying, this is your basically a home page of your repository, you can say. And then, like I was saying, you have the license. So here the license is a GNU GPL v3, like I said. So anybody who forks this repository will be forced to make it open source. Like they cannot have a public version of it. And that's what a that's the so now yeah. So now if you're a user who wants to contribute to this, what would you do? The first step would be, like I said, fork it. You would fork it. The option to fork is right here, and this will take you to your own copy of the repository. Like I'll show you an example of a fork. Yeah, so this is a forked repository. So like it says, even though I can make changes to this, it's originally from somebody else. Like it says fork from. So this is a fork repository. So once you have a fork repository like this, you're gonna clone it. You would it's not now you have three options to clone. So use the HTTPS one because we do not use SSH. Like you have internet access, so just use HTTP S1. So this would be your copy the URL, and then so um, go to your command line and do like a git clone. Like, so yeah, every time you git clone is just a command. So it will show you all. If you just do git clone, then it'll just show because it doesn't know what to clone. So it'll just show you all the options, and it'll just say specify a repository to clone. So then you'll do git clone. Sorry. Yeah. So now this repository, I have a copy of it on my file system as well. So like legit, all the same files. So now if I want to like make changes to this, I would modify something, and then I would like suppose I say okay, add a line here. Okay, hi, this is 10. So imagine that this is a code change, and now I'm like, okay, this is a feature that's pretty much done. I should make a checkpoint here in case I want to make more changes and we still have the ability to come back to this point. So then I would go git commit. And so git commit is a command for making a commit, and then you would write in the update like saying, make sure that it's not something random because you would be the person that's rereading it, and it should make sense to you at the end of the day. Yeah. So, like I said, oh, I'm sorry, I made a mistake. So before you commit, you have to add all the files that you want to commit in its current state. So basically, I can make changes to multiple files and then add it as a single commit. Like I have just made a login page. So that would involve me making changes to the JavaScript file, to the HTML file, to the CSS file. So all of these things shouldn't be a separate commit. They should all be a same commit, or it can be a separate commit. If you want it to be a same commit, then you add all of these by git add. And it's very important that, see, if you do git add dot, then all of your files get added to the commit state. So but that's not really nice practice because um, sometimes most of your files are just configuration files and they're built at every, so every time you build the application they'll be rebuilt. Like you don't really need it, you need to back it up on GitHub. So don't do GitHub because especially for Android apps and like stuff, there are a lot of config files, and that's just useless space that's wasted, useful space that's wasted. So make sure you're specific with the file name that you're committing, add it to the commit uh, thing, and then you can commit. And then it will say get 6 insertions or whatever. So now if you do git log, you can see that I made a commit. And as I said, every commit is associated with a random string. And this is a hash function. It's like a cryptographic hash sort of thing. So this is how you identify every commit. Like I make some changes, and now suppose I'm like, oh, I do not want this update that I just made. I want to go back here. and then I have the ability to go back. Like I can move between commits, etc. So that was something about commits. So now this has also given me, sorry, queue. Yeah. So now if I want to push the changes that I just made to this repository on GitHub, I would say git push. And if you're doing this for the first time, then it'll ask for your GitHub credentials. And now that GitHub has stopped accepting username and password as credentials, you'll have to generate a token and then use that. But it's not much of a pain. It's just a one-time thing. So now if you refresh this, you can see that README was just updated 1 minute ago. And you can see that there would be something here that's not supposed to be. But yeah, it's appeared here. So that was a little bit about how to do basic operations. I mean, you will have to do the proper tutorials if you really want to learn more. Yeah. So, like as I said, this is a fork, so it always has an upstream because it was forked out of somewhere. And right now, it says that this is not the like it says the branch is 15 commits behind the upstream. As in, after I forked this repository, the original repository was changed 15 times with 15 different commits. So this is what you should avoid. You should always be equal or like a one or like try to be not behind commits because that would just lead you to be developing on an old code base, you could say. So that was something about that. And yeah, now let's go for pull request. I'll show you how an open pull request looks. Reiterating, a pull request has nothing to do with a pull from your side. It's just a merge request. Like, yeah. So imagine that my forked repository had some new features which I just pushed, like you saw me do in the other repository. Now I want to merge it with its forked. Let me just do it there. Yeah, sure. Let me just go back there and make a pull request. So yeah. So I go to this pull request, new pull request. So here it would like ask me where do I want to submit the pull request from, etc. Or you can also do this, like compare across forks. So once a pull request is open, it would look something like this. So there might be multiple people giving pull requests, so like they'll all be stacked over here. So you're required to give like a proper pull request message. I mean, this is a very basic one. I mean, I would say don't make it this basic that I don't know what this means. Like fixed error where DB was replaced by like I as a maintainer do not know what this means. So do not do this. Write it detailedly. How does this impact the project, etc. And then it would be reviewed. Like now, um it says now automatically once you create the pull request, uh, make sure it GitHub automatically checks if there is a conflict, and if there's a conflict, then it'll say it cannot be merged. Otherwise, it'll say yeah, good to go, no conflicts, merge it. So the maintainer would say okay, merged. So now uh, the change that my friend made has been accepted into the main code base. So that's how a pull request works. That's why contributions are measured in terms of pull requests. It's the number of times that you added a feature or a useful thing to a repository. Uh, in case you want to see, like, I was really bad at writing pull requests, and then during my GSOC time, they were like, please write better pull requests. So if you want to see an example of an okay pull request, that would be, show you that in a second.
We have a question.
Yeah. Hi. Yeah. So, yeah, you're right. That does happen. And which is why you should work in branches. That's also the use of branches because, like I said, your main branch will always be modified by something or the other because multiple people are working on it. You fetch upstream, your change will be overwritten. But if your pull request gets, if you work in a branch in your own repository, then it won't be overwritten by a pull request. In this case, what you'll have to do is you will have to rebase. So you suppose you're working in a branch and that's like a little out of, it's a little older than the original repository. So you will have to rebase your repository with the original repository. So the changes are made in chronological order stacked over each other. And at the end, you will have a repository that's both up to date and which has your changes as well. Does that make sense a bit? That's how you get around this, like getting overwritten by new commits. Yeah, just a sec. Oh, I'm sorry. Coming to quality PRs. Yeah, let's see. This must have something. All right. Let me go to. Yeah. So, like, usually in a pull request, you write everything that was done, like all the changes that were made, so that the person who is maintaining a repository just understand. So, please do write proper pull request because people after you will read it every single time they go through the repository. And it's just easier to get your PR accepted if you write proper descriptive merge requests. Like, and you can insert pictures, you can provide links, you can leave documentation, anything, but make sure it's good. And that's about pull requests and like uh, anything else. So that would be all from my side. But if you do have questions, I can take them. And of course, do fill in the review form that comes to you from Google Developer Society because it's important to plan such events and like for everybody, for the society in general. So if there's anything specific you want to learn, please share it and like just say if this was helpful at all. It's a good thing to do. And this is YouTube, so like, share, and subscribe. That was mandatory. Hopefully, this helped. I know things were probably not that clear because the first time I got introduced to Git, it was a total mess. And it's okay, you learn. And it's better if you learn early because then it's just very efficient way to work and like to keep your work and to keep code in general. So that was my very small introduction to Git and GitHub. Hopefully, I did not speak for too long. Um, so, any questions or should we end this? Okay, seems like that's all for today. Have a good day. Bye.
Thanks a lot for the event, Danya. And all the links that Tanya mentioned would be in the description below. And if there are any specific links that we would like to add after, we will be adding in the pinned comments or in the description. So if you're watching this video later, please do visit the description and see it. And also, please do fill in the post-event form that you receive via your email if you have RSVP'd to the event, so that we'll get a better understanding of what events we need to be planning further. And yes, stay safe. And if you have any questions, you can leave it to the GDSC chapter. You can also join our Discord server, which all the links to that are in the description below. So even if you have any question later, you can just drop it in there and we would be more than happy to help you out. So yeah, I think that's for today. Let's wrap up.
Sure.
Yep.
Bye, everyone.
Yep. Bye, everyone. Bye.